Alright, welcome everyone. Today we're going to look at Lesson 8-1A Notes Operations with Radicals. We have our table of perfect squares, which we will need, but we've already talked about this back in Unit 7, okay? So I'm not going to go over this again, but this is going to be very, very important as we answer some questions here. Alright, so what we're going to do is we're going to look at the properties of square roots. We have, first off, the product property, which states that for every number m greater than or equal to 0 and n greater than or equal to 0, if we have the square root of m times n, we can rewrite that as the square root of m times the square root of n. Or if you're given this, let's say you have the square root of m times the square root of n, I can rewrite this as the square root of m times n, okay? So this is the product property. The quotient property states that for every number m greater than or equal to 0 and n greater than or equal to 0, if you're given the square root of m divided by n, you can rewrite this as the square root of m over the square root of n. Or, if you're given the square root of m over the square root of n, you can rewrite that as the square root of m over n. Okay? Alright, so we have the product property down and the quotient property. Let's go ahead and look at simplifying radicals and other operations with radicals. So here we go, multiplying radicals. To multiply radicals, you multiply the coefficient to coefficient, so these things here are the coefficients, and then the radicand to the radicand. So the numbers under the roots are the radicands. So this is a radicand and this is a radicand. Once you have multiplied the radicands, make sure that the radical is simplified. So this is very important. When you're done with the multiplication side of things, you need to make sure that your answer is simplified to the fullest extent. Okay? You may have to simplify it further to make sure you may have to simplify it further to make sure that the answer is in simplified radical form. Okay? So here we go. We have 4 times the square root of 3 times 5 times the square root of 8. I have the 4 and the 5, those are the coefficients, so I'm going to write 4 and 5 here, so 4 times 5. And then I have the square root of 3 times the square root of 8. These two things are my radicands, so we're going to multiply them together. So I have the square root of 3 times the square root of 8, and then I can go ahead and multiply the coefficients now. So 4 times 5, that's 20, and then the square root of 3 times the square root of 8, that's going to be the square root of 24. Okay? So now what I'm going to do is I'm going to simplify this. Y'all, we can see that we have the square root of 24. So I'm going to pick my two numbers that multiply together. That'll give me 24. And one of them will be a perfect square, okay? So 4 and 6. 4 is the perfect square here. So I can break that down 2 and 2, right? So now I'm going to circle. And you know what to do here. One of the 2's will come out and the other one will be eliminated, right? And then the 6, I can't take the square root of that, so it's going to remain under the radical. So what we have is this. We have 20 times the 2 times the square root of 6. And our answer is going to be 40 times the square root of 6. And that's our answer. Okay? Alright, so now we have an idea on how to multiply radicals. We're going to learn how to divide radicals and also this idea of rationalizing the denominator. So, there can never be radicals left in the denominator of a fraction. If there is a radical in the denominator, you will rationalize the denominator. You will rationalize the denominator. And to do this, you multiply the numerator and the denominator by whatever radical you have in the denominator. Okay? So, let's take a look at what we have here. We have 7 divided by the square root of 3. So you can't leave your answer like this because you have a radical in the denominator. So we have to rationalize the denominator. So I have that square root of 3, right? So what you need to do is you need to multiply the bottom and the top by whatever appears in the denominator. So I have the square root of 3, so I'm going to multiply the bottom by the square root of 3, and whatever I do down below I have to do up top as well. So I'm going to multiply the top by the square root of 3. And whenever we multiply fractions, we always multiply across. So 7 times the square root of 3, well, that's just going to be 7 times the square root of 3, okay? And then you have the square root of 3 times the square root of 3, which you can rewrite as the square root of 3 times 3, right? And we know what the square root of 3 times 3 is. That's going to be the square root of 9, okay? Now what you need to do is you're going to keep on simplifying. 7 times the square root of 3, you're just going to leave that alone. But the square root of 9... right? 9 is a perfect square. 9 is a perfect square. So if I take the square root of 9, you're going to get 3. So your answer should be 7 times the square root of 3 divided by 3. And you're done. Okay? So now what we're going to do is we're going to get into the territory of examples. We have number 1. We have the square root of 15 times the square root of 54. So looking at this, I can use that product property, and it's in this form. I can rewrite it in that form here. So the square root of m times the square root of n, I can rewrite that as the square root of m times n. So here we go. I have the square root of 15 times 54. And I'm going to be using that method number 1 from, back in Unit 7. So we're not going to use the factor tree. I'm just going to use that square root, or break it down in the square roots, if that makes sense. So here's the thing. We're going to use those ideas that we've been doing with simplifying radicals. I have the square root of 15 times 54. What I like to do here is I'm just going to go ahead and break down this 15, and the two numbers that work here are 5 and 3, right? So 5 times 3 is 15. And then here I have the square root of 54, or just the 54 here. I can think of two numbers that multiply together that'll give me 54, where one of them is a perfect square. So then what I'm going to do is, first of all, I'm going to go ahead and throw in the multiplication sign and say 9 times 6, right? So 9 times 6 is 54. And then I can look at what I have now. I can't break down the 5, I can't break down the 3, but I definitely can break down the 9, because look, the square root of 9, y'all, that's just going to be 3. But let me go ahead and just rewrite 9 as 3 times 3, and then we have that 6, right? So let's break that down too, just in case. Just like that, right? 3 times 2. Alright, so now what I want to do is I want to look for pairs. So I notice that we have a pair of 3s, and we have another pair of 3s. And then we have the 5 here and the 2. So let's go ahead and build our answer. So I have 3 times 3 root 5 times 2. So 3 times 3, that's 9. Root 5 times 2, that's 10. So your answer should be 9 times the square root of 10. Okay? That's how you do it. Number 2, we're going to go ahead and, again, multiply radicals. So we're going to multiply the coefficient to the coefficient. I can see that we have two coefficients here. And then the radicand to the radicand. So coefficient to coefficient, and then radicand to radicand. Oops, that's really dark to see. That's 11 and 8 there. So then I can go ahead and say negative 3 times 6 times the square root of 11 times 8. So then we have negative 3 times 6 root. Can't break down that 11, so I'm going to leave it alone. But I can break down this 8. So what are the two numbers that multiply together that will give you 8? I'm thinking 4 times 2, right? We can take the square root of 4, but we can't take the square root of 11 and 2, right? So once I take the square root of 4, which is 2, it's going to come outside of the radical, right? So that's going to be negative 3 times 6 times 2. Don't need this anymore. And then we have the 11 and the 2. So 11 times 2 under the radical. And now I can go ahead and simplify this. So negative 3 times 6, that's negative 18. Negative 18 times 2, that's negative 36. So negative 36 root 11 times 2, 22. Okay? So that's your answer. All right. Okay, let's take a look at number 3. We have negative 2 times the square root of 5, the quantity squared. Y'all, if we remember, we have negative 4, the quantity squared. That can be rewritten as negative 4 times negative 4, right? So that's just what? 16. Okay? If I were to give you something like the square root of 3, the quantity squared, you can rewrite that as the square root of 3 times the square root of 3, right? So the square root of 3 times the square root of 3, that's the square root of 9. So basically, if a square root is multiplied by itself, it's just whatever appears under the radical, right? So your answer is 3. Sorry if it's hard to see. If I were to give you the square root of 2, the quantity squared, that's just the square root of 2 times the square root of 2, or the square root of 2 times 2, which is the square root of 4, or just 2. Okay? So some things that, you need to know, and they're pretty easy to remember. So we have number 3, negative 2 root 5, the quantity squared. You can rewrite that as negative 2 root 5 times negative 2 root 5. And then we're going to go ahead and apply this again. So we're going to multiply the coefficient to coefficient. And then the radicand and the radicand together being multiplied. Negative 2 times negative 2, that's positive 4. And then root 5 times root 5, just like this root 3 times root 3, that's going to give me 3. And then this root 2 times root 2, that's going to give me 2. You know for sure that's just going to be 5, right? So 4 times 5, and that's going to give you 20. Okay, let's take a look at number 4. 4 root 3, the quantity squared. So 4 root 3 times 4 root 3. And then 4 times 4 times the square root of 3 times the square root of 3. Should put a little multiplication sign right there. And then that's going to give me 16 times square root of 3 times square root of 3. That's 3. So 16 times 3, that is 48. Okay. So that's your answer. And I want to go ahead and just take a moment and let me go ahead and pull out a piece of paper, show you some shortcuts. So if I look at number 3 again, we have negative 2 root 5, the quantity squared. Well, this is what I'm going to do. See this negative 2 and this square root of 5? I'm going to go ahead and rewrite those here. Negative 2 with the parentheses times square root of 5 with the parentheses. We have this exponent of 2 here. So what we're going to do is we're going to distribute those 2's. Or sorry, we're going to distribute the exponent of 2 to each of these values here. So this gets a 2, and this gets a 2. -2, the quantity square, that's basically, you know, -2 times -2, right? And over here, that's the square root of 5 times the square root of 5. And that's going to give you 4 times the square root of 5 times the square root of 5. It's 5. So your answer is 20. Okay, that's a shortcut. We can do the same thing for number 4 here. So let me go ahead and rewrite 4. So 4 is 4 times the square root of 3, quantity squared. Alright, so then I'm going to go ahead and write 4 and write the square root of 3. We have the exponent of 2 floating above. So we're going to go ahead and put a 2 here and a 2 there. 4 times 4, square root of 3 times square root of 3. 4 times 4 is 16 times square root of 3 times the square root of 3. That's 3. And we said that 16 times 3 is 48. That's your answer. Okay? Alright, number 5, we have the square root of 200 divided by the square root of 8. I can go ahead and rewrite this into this, right? So I can go ahead and say the square root of 200 divided by the square root of 8 is the same thing as saying the square root of 200 divided by 8. And I want to go ahead and look at my calculator real quick and just see if anything good happens. Let's see, 200 divided by 8. Ooh, that's going to give me 25. So I can basically do stuff under the radical here and just say 200 divided by 8 is 25. But don't forget we have the square root, so we're really taking the square root of 25. And 25 is indeed a perfect square, right? So the square root of 25, we know for sure is 5. And that's your answer. Number 6, we have 6 divided by the square root of 12. Okay, so you can't have a radical in the denominator. So what you need to do is you need to rationalize it, right? So what we need to do here is we're going to multiply the bottom and the top by whatever appears in the denominator. So I'm going to multiply the bottom by the square root of 12, and I need to multiply the top by the square root of 12. And now we're going to multiply across. So the square root of 12 times the square root of 12, that's really easy. That's just 12. And then we have 6 times the square root of 12, which is just 6 root 12. Okay. And what I need to do is just take a moment and check to see if I can simplify this radical here. So we have the square root of 12. So let me just rewrite this as 6 times the square root all over 12. And now what I'm going to do is I'm going to think of two numbers that multiply together that will give me 12. And again, I like to use a perfect square for one of the numbers here. I'm thinking 4 and 3, right? I can take the square root of 4, but I cannot take the square root of 3. So once I take the square root of 4, that's going to give me 2. 2 is going to go outside of the radical, right? So I have 6 times the square root of 4, which is just 2. So it's going to go outside of the radical, right? And then I'm going to have my square root here. The square root of 3, you can't take the square root of that, so that 3 is going to go inside the radical there. Divide by 12. 6 times 2, that is 12. Divided by 12. And then we have that root 3. So look at our answer right now. It looks really weird because what we can do now is this. I can actually simplify, ignore this radical right now and think of this 12 over 12 as it is, right? You can simplify that. You can simplify your fractions. That's just going to cancel. Those two 12s are going to cancel, and you're left with the square root of 3, okay? A little side note, let's say that you have 6 root 3 over 12, okay? So this is what you have, but you notice that you could simplify this, right? You have that 6, you have that 12, you can actually reduce that to 1 root 3 over 6, and that would be your answer. Okay? Just a quick side note. Let's take a look at number 7 here. We have 3 times the square root of 5 over the square root of 7. So now what we're going to do is we're going to rationalize the denominator. Okay, we multiply across. So I have 3 times the square root of 5 times 7 all over the square root of 7 times 7, or just 7, right? And then I can go ahead and just check to see if I need to break anything down here. I can't break down the 5 and I cannot break down the 7. So your answer is 3 root 35 over 7. There you go. We have number 8, 2 times the square root of 3 divided by 12. I noticed that we have a fraction here, 3 over 12, and I can actually simplify this, right? This can become 2 root 1 over 4. And then I can go ahead and apply this rule here. If you have the square root of m divided by the square root of n, you can rewrite that as the square root of m over the square root of n. So let's go ahead and do that. I have 2 times the square root of 1 over the square root of 4. So we have 2 times the square root of 1. The square root of 1, y'all, that's just 1. And then we have the square root of 4, which is just 2. So 2 times 1, of course, that's 2. And then you don't do anything in the denominator. And then we have 2 divided by 2. You know for sure that's 1. Okay? Please remember this. If I give you 5 times the square root of, 6 over 10, and this is what you're left with, please make sure that you simplify this. That should be 1 root 6 over 2. Yeah, so just make sure that you know how to simplify something like that. Okay? Alright, we're going to go ahead and look at the back side of the notes.
Alright, so let's go ahead and take a look at the back side of the notes for 8-1A. We are going to get into the territory of Algebra 2. We are going to add and subtract radicals. Now, in order to add or subtract radicals, you must have the same index and the same radicand. So if I were to give you an example, we have this, we see a 3, we see a radical, and we have a number under the radical, which is 8. So one thing to note, this floating number here, that is what we call the index. And this number under the radical is what we call the radicand. So in general, if you see a 3 and a square root, or just the radical, it's not really the square root here, this is basically taking the cubic root of 8, right? So if I were to take the cubic root of 8, you can tell me what number raised to the third power is going to give you 8. So that's essentially it, right? So I would just say 2, right? If you were to take the cubic root of 8, that would be 2, but I really don't, need to worry about that right now. I just want to go ahead and just differentiate what the index is and the radicand, okay? If you were to take the square root in general, right? So if you were to take the square root of 16, right? If I were to take the square root of 16, the index of taking the square root of any number is always 2. But we don't need to write that because we all know what the square root looks like, right? So when we take the square root of 16, you can tell me 4. You don't need to write out the index. But when we're doing that for, let's say, taking the cubic root of a number, of course, we need to be very, very clear about what the index is, okay? But for taking the square root, the unwritten index is 2. So let's take a look at this right here. I can add or subtract these examples. The first example is 5 root 2 minus 3 root 2. Of course, we can see that they have the same radicand. They both have that square root of 2. And then this unwritten number here and there, of course, that's just going to be 2 because I'm taking the square root. So again, to add or subtract radicals, you must have the same index and the same radicand. So here we go. Just like combining like terms here. Again, the indices are 2 and the radicands are 2 here. So I can go ahead and say 5 root 2 minus 3 root 2. How many root 2s are there? There are 2 root 2s. If that makes sense, right? So 5 minus 3, of course, that's 2. And then you're going to keep the root 2 in your answer. For this example here, we have 2 times the cubic root of 2x plus the cubic root of 2x. We have the same radicands, and we do have the same indices. So both of them are 3s, right? So I can go ahead and combine. So I have the coefficient here, that's 2, and then this invisible number should be 1. So 2 plus 1, of course, that's 3. And then we're going to go ahead and slap on that cubic root of 2x, and that's your answer. Let's take a look at some examples of cannot add or subtract. We cannot add or subtract these examples here. I have the square root of 3 minus the square root of 8. Notice that we have different radicands. Of course, we do have the same indices. This is, me taking the square root of 3 and me taking the square root of 8 here. So the unwritten index for that one is 2, and the unwritten index for that one as well is 2. Again, they have different radicands, so I can't combine here. For this example, yes, I can see that we have the same radicands, but this has an index of 3, and this one has an index of 2. So you cannot combine these 2 terms at all. So what we're going to do now is we're going to look at number 9. I have 6 root 7 plus 3 root 7. And because we have the same indices, they both have a 2, and we have the same radicands, they both have the square root of 7, I can definitely combine these 2 things. So how many root 7s are there? There are 9 root 7s. Okay, so that's number 9. Number 10, just like number 9 here, we have 2 root 3 minus 6 root 3. So they have an index of 2 here and an index of 2. So let's take a look at the radicands. They both have the square root of 3s. So yes, I can combine these 2 terms. So 2 minus 6, that's negative 4. How many root 3s are there? There are negative 4 root 3. So that's your answer for 10. For number 11, this one's a little weird because look, 8 root 3 plus 2 root 27. What I want to do here is I want to check and see if I can simplify this and see if there's anything good happening from there. And what I mean by that is let's take a look at this 8 root 3. We're going to leave that alone, plus 2 root 27, right? So 2 root 27. I can actually break down that 27 with 2 numbers, where one of them is a perfect square. So 2 root 9 times 3, right? 9 being the perfect square, multiplied by 3, that's going to give you 27. And then I can go ahead and keep going from there. So I have that 2. I can take the square root of 9. The square root of 9 is 3. So where is 3 going to go? It's going to go outside of the radical. And then I have that 3 under the radical. You can't take the square root of 3, so it's going to remain under the radical here, okay? So now what I'm going to do is I'm going to simplify. I have 8 root 3 plus 2 times 3, that's 6 root 3. And guess what? I have the same indices, right? There's an invisible 2 here and there. And we both have the same radicand, so I can definitely combine these 2 terms. So 8 plus 6, that's 14. 14 root 3. I can do the same thing for number 12 right here. So 6 root 2 minus, let's break down the square root of 50. Well, what are the 2 numbers that multiply together, where one of them's a perfect square, by the way? We'll give you 50. I'm thinking 25 and 2. So let's keep going. 6 root 2 minus the square root of 25, that's just 5 root 2. Now, look, 6 root 2 minus 5 root 2, same indices, same radicands. I can definitely combine that. So 6 minus 5, that's 1 root 2, or you can just say the square root of 2. Number 13, we have 8 root 3 plus 2 times the cubic root of 7. Notice that this is invisible, so the index for this term is 2, but for this term, it has an index of 3. And they have different radicands, so you really cannot combine these 2 terms at all, okay? Number 14, I have x times the square root of 48 plus 2x times the square root of 12. So what I'm going to do is let's break down the 48 here and the 12 and see what happens. I have x times, what are the 2 numbers that multiply together will give you 48? Remember, we want one of them to be a perfect square. I'm thinking 16 and 3. Plus 2x root. We have this square root of 12 here. So what are the 2 numbers? I'm thinking 4 and 3. And now I can go ahead and look at what I have now. The square root of 16, the square root of 16, that's 4. 4 is going to go outside of the radical. So 4 times x root 3 plus, I have the square root of 4. I can take the square root of that, but I cannot take the square root of 3, right? So the square root of 4 is 2, so it's going to go outside of the radical. So 2 times 2x root 3. So now what I have is 4x root 3 plus 4x root 3. And we have the same indices. Both of them have an index of 2, and we have the same radicand. So with those 2 things, I can definitely combine these 2 terms here. So 4x plus 4x, that's 8x root 3. That's your answer for number 14. Number 15, I have 3 times the square root of 2 plus 5 times the square root of 2 minus 16 times the square root of 2. Notice that we have the same indices. Here's a 2, here's a 2, and here's a 2. And we have the same radicands, so I can combine all of these terms. And because we need to consider order of operations here, we have to go from left to right, right? So 3 root 2 plus 5 root 2, that's 8 root 2 minus 16 root 2. So what is that going to give me? That's going to give me negative 8 root 2. For number 16, we have 4 times the square root of 5 times 4 times the square root of 2 plus 6 times the square root of 10 minus 8 times the square root of 10. Now, here's the thing. Again, with order of operations, we have to multiply first before we add or subtract. So looking at this guy here, actually, when we look at 4 root 5 times 4 root 2, we can apply that rule where we multiply the coefficient to the coefficient, so 4 times 4, and the radicand to the radicand, so root 5 times root 2, yes, plus 6 root 10 minus 8 root 10. Now, let's take a look at this thing here. 4 times 4, that's 16, and then we have that root 5 times root 2, which I can rewrite as 16 times the square root of 5 times 2. And then I'm going to go ahead and keep the other ones. And then I can go ahead and simplify this. So that's going to look like, what, 16 root 10 plus 6 root 10 minus 8 root 10. And look at that. We have the same indices. They all have an index of 2. And all of these terms have a square root of 10. So essentially we have the same radicands. So we're going to go ahead and combine. So 16 plus 6. We're going to go from left to right because, again, we have to take into consideration of order of operations. So 16 plus 6, that's what? 22 root 10 minus 8 root 10. 22 minus 8, that's just 14. So 14 root 10 is your answer for number 16. Okay? All right.